Hello, everyone. Welcome to our webinar. My name is Grunewald from Digital Consulting House. And I'm with me here with my team members, with Mr. Tom Gottweis, with Mr. Christoph Wesselburg, Mr. Sumit Ray, Mr. Alexander Grunewald, so wearing the same last name like I do. I'm happy that you are here, and I want to thank you very much for taking your lunch break or whatever time, wherever you are in the world, you have allotted to it. We really appreciate that you took the time to spend maybe half an hour to an hour with us. Right? We have a good program. So for today, we are talking about artificial intelligence and machine learning, and how it also can transform your business, in particular when it comes to the subject of product master data management. And that is what we at Digital Consulting House predominantly do. Maybe a little housekeeping or a couple of housekeeping items. First of all, this event is being recorded. We will use the recording for marketing purposes and social media. We make sure that individuals and individual data will not be distributed to anyone in the outside world. We will not use your data. We will not sell it to other parties. All of that will not happen with us. Right? So the other housekeeping item is that this presentation, apart from that, there will be a recording which will be provided a couple of days after this meeting. There's also a presentation deck. We will provide that as well, so that you have some material. And of course, you can always contact us, ask questions. And having said all this, I jump right into the subject. Today, what are we talking about? First of all, we'll do a very brief introduction into Digital Consulting House and what we are doing and what is product information management. And then I will hand over to the host of this meeting. His name is Alexander Grunewald, and he doesn't have the same last name like I do by chance. He is the vice president of the Artificial Intelligence Club at Michigan State University, and he was so nice, willing to provide us the opportunity to talk a little bit about what he's doing here. We are actually right now at the premises of Michigan State University here. So so let's get started with a little introduction. Who are we? So what we are predominantly doing is anything around master data management, digital publishing, and digital marketing in general, but with a strong focus on helping manufacturers and distributors and retailers use their product information to do better business. Right? And well, as you see the marketing claim here in my back, we are here to make the complex simple. It's a very complex subject, a very complex world. And we provide services which help you to take a little bit out of the complexities, because we will help you taking care for them in the right way, simplify your processes, and basically also use master data management to transform your business. We started 2013. Originally, I served as the vice president and professional service and consulting of a company called Hyla Software. Hyla Software was at that point already one of the leading vendors of PIM software, product information management software. Well, 2013, the company called Informatica took over. And since then, we are in this business. It's now already the 10th anniversary, which passed in March. 2015, we also started our German entity to serve our European customers, Digital Consulting House GmbH. And apart from that, we have a couple of places in which some of our team members reside. For instance, India, Mr. Rai, our Director of Sales and Marketing, is located in Delhi. We have also some people in Guadalajara, in Mexico. And Mr. Gottweis, President of the company and my partner, he is located in Dayton, Ohio. And Chris Westerburg, who is our expert for digital publishing, is in Tampa, Florida. So I think we have a good geographical coverage here as well. We have this slide here, which shows you, tells you a little bit about us. I'm just focusing here on what we are doing from a service perspective, as I already said, product information management, MDM. We are experienced with software products like Informatica, both prem and software as a service, Fibo, InRiver, Riversand, Akineo, you name it. Right, where we have quite a run over the years with multiple different companies. Can everyone who is not talking please put themselves on mute? Right, I will right now. Thank you very much. I really appreciate that. So MDM, PIM advisory, PIM implementation, database publications. So that's what Mr. Wesselburg in particular has the expertise on, and some of our other team members. They are products like Print, Comet, or Easy Catalog, or Stibo. Stibo have their own product too. We have some experience with. And then nowadays, it's all about also integrating all these different platforms, which we know a little bit of. Data stewardship, taxonomy, AI and machine learning becomes more and more relevant. Well, we are lucky to have one of the experts in our team as well. And of course, we are providing training as well. Right. So we are like, unlike, or actually like a lot of other service companies who all claim they are the best. We really have in our ranks the people who have 20, 30 years of experience in IT, who have done MDM and PIM, and we're working with our own resources, right? So we are not in the position that when we start a project with you, we have to look around and find the people. We always see that. We always know when a larger business starts a project, because then all the Indian recruiters come out and try to hire us. That's quite funny, actually, because then you have 10 recruiters for one position who are trying to get you. Right, we predominantly worked in electrical and medical industry. So subject like ETIM, BMECAT, IDEA, DDS, that's also not foreign to us. And also we know customer goods, grocery very well. We work with some of the larger grocery chains on this planet. I can't say the names, but these are all household names you very well known, I believe. Yeah, and having said that, I think that now enough about Digital Consulting House, and I would like to hand over, no, almost, because I quickly want to talk about product information management as well, right? So, so this is our definition of product information management. So product information management in our world is not just a software, right? There are many different tools which you can use to manage your product data, but it's all about the process, having the organization in place, having the knowledge in place, know what you are doing, and then also the tools. But the tool is just one aspect. So there is a definition which we quite like from Techopedia, which is that product information management refers to the processes which are used to evaluate, identify, store, and manage and distribute product data and information. And what is what people want to achieve by doing this? There are clear business reasons for it, like getting faster to the market, having higher conversion rates, having higher revenue, and also making more money, having higher margin. Okay, but now I'm at the point that I would like to hand over and introduce you to you, Mr. Alexander Grunewald. And I turn over the camera to make sure that you are actually seeing him. Let me put that on. Very well. Okay, Alexander, please.
Yes. So, hello, everyone. Before I get started talking about different types of AI models that there are and which one could fit a certain problem that you might have, I want to first discuss some of the main differences or clarify on what artificial intelligence actually is, because it seems that a lot of the times machine learning and artificial intelligence gets interchanged very frequently, even though they're not necessarily the same thing. Think of artificial intelligence as something where a computer or a machine is trying to emulate, simulate human intelligence that would drive decisions. Machine learning, on the other hand, is mostly something where decision is driven by data to create some sort of statistical model to drive those decisions. AI also empowers automates learning from the data. Certain models do that. And some examples, for instance, what is not a machine learning model, but rather more of artificial intelligence is, for instance, like a chatbot that uses regular expressions. Some of the first chatbots actually, such as Eliza, use these regular expressions where it just looks through a text and responds based on some common phrases. Like, for instance, if I were to say, hello, how are you? It would respond like, yes, hello, I'm doing fine. What can I do for you? Eliza was a therapy pod, actually. So based on anything that you said, it would try to make a human response, but it wasn't trained on anything like data. So this isn't machine learning. On the other hand, like something like sales forecasts, where you have previous data and you're trying to predict sales or revenues in the next coming years, you actually are creating a model, a statistical model, that will learn from the data that you have previously and try to forecast something in the future. Something like deep learning is mostly in the realms of neural networks, such as game bots that we see. So further, something's finished.
Oh, sorry.
Yeah. Oops. So then further, I want to discuss now which models you could use for which tasks. Now that we have a better understanding of what artificial intelligence is, and that we know now it's much more of an umbrella term. There is a paradigm that I've learned in one of my classes called the GET, where you want to have to first establish a goal. For instance, you want to classify a product based on certain features. And for that, we need experience for the model to learn on, to train on, which is the data set. And we want to test how well our model is doing, which will use some sort of performance metric. In this case, we would use accuracy, where we can see how many times it misclassified a product for something else or classified correctly. And then we also want some way to test the model by having a testing data set, some sort of data that the model has never seen before. So some of the most important questions that you need to answer yourself is with the data that you already have. Is your data labeled? Is it maybe too large for a model to train on? Are there any sort of like missing values? How clean is your data? And all these facts about your data will influence which kinds of model you want to use. So one of the things is like supervised learning. Supervised learning uses labeled data for classifications, for instance. Let's say I want to classify this common data set that a lot of people have maybe heard about, called the iris data set, where you have petal length and sepal length of your flowers, and you want to classify which kind of flower it is. Is it Iris setosa, veronica, or virginica? And we can use a model to use a couple features and then create some sort of decision boundary to classify whatever the labels are. This could also be products. So for instance, if I want to create a decision boundary based on what a shoe is or a t-shirt, I could make that happen. On the other hand, also another supervised is regression, where I have some X variable and a Y variable. And I want to, the Y variable is like your dependent variable, where I want to predict what kind of price it is. Your X could be like a time. And so you can do some forecasting. If you don't have anything labeled in your data, if you have no labels in your data, aka no Y, then I would want to use some sort of unsupervised learning technique. For instance, if your data set is too large, or you want to find some structure in your data by visualizing it in a lower dimensional field, we could use something like dimensionality reduction methods, where, for example, we have this so-called Swiss roll, and we want to put it onto a lower dimensional space, and we can see the structure of how the data looks like much clearly. You could even think this would be like a 4 or 6 dimensional data set, and I can collapse everything down to 2 dimensions or 3 dimensions, and I just visualize that. Another unsupervised learning technique, if I don't have any labels, is clustering, where you can create your labels artificially by creating some sort of clusters. For instance, in that picture, you have a cluster there, a cluster here. So it looks like you have like 3 different things that you may want to classify in your data. Oops. Thanks. Yeah. Okay. So then everything boils down to these different machine learning models that you could use. So we have, again, the unsupervised and supervised learning. And I really like this figure here, because it also gives you some examples of certain problems that you might have. For instance, I could use supervised learning classification, and then I want to do image classifications, like classifying an apple from a banana. Or I could do unsupervised learning and go into clustering and do maybe something like anomaly detection, where if I have a huge group of normal things that I see, and then I have some sort of outlier over here, for instance, email spam, then I could classify that and could flag an email for being considered spam, for instance. Now, a big thing that I need to discuss now is, how do AI models actually work? Really, you're trying to minimize some sort of error function or loss function, as we call it. You can think of it like trying to fit a line through points in your data. You've probably done that in a middle school or high school, where you have a bunch of data points and you're trying to fit a line of best fit. That's really like what regression models are doing in any kind of like high dimensional space, or even 2 dimensions. We're trying to fit some sort of plane to minimize the distances between all of these points, so that you can create a prediction further out, or prediction somewhere in the x-axis to do that. And one of the matrices is, for instance, root mean squared error. If you go into the next one, there's a 3D representation of how a loss function could look like. You can think of yourself being on top of a hill, and you're trying to find the minimum of that hill. That's exactly what a machine learning model is doing. It starts somewhere on this plane, and it tries to walk down and find where the error is the lowest. So in that case, it starts up there in the Gauss, somewhere up there in that hill, and it goes down to a saddle point, which are like a minimum, one of the local minimums. And there's a problem. You can see that there are multiple minimas in that graph, where all of these could be possible solutions, and it might not be the most optimal solution. So it's always very difficult for these machine learning models to find the best or optimal solution to create the least error in these predictions. So now I'm going to talk about some more examples and applications towards MDM and a demo. So one of the things that you could do is perhaps some sort of automatic product detection and classification. where I have an image, for instance, and I want to be able to identify what kind of product that is. If you have, for instance, a lot of features, for instance, the height, the material, what kind of components that specific product it has, I can use all of that data or even image to create a product classification. Like this is, for instance, a Mercedes-Benz car or an inverter or a live lobster, based on some of those data values that I have. You can also do data quality detection. So for instance, if you have a lot of like messy data in your MDM, I think maybe Cassandra or some other models in Informatica can do that, where it can classify whether or not how clean your data is. Let's see this next. And then another way to do it is you can use a large language model like a generative pre-trained transformer or a GPT to create these long or short descriptions of your products. For instance, if I have a lot of different features, I can put all of that in through an API call to GPT and tell it, hey, can you please generate some sort of long product description or short product description in this format? I would give it an example, and then it would be able to generate that kind of long or short description. If you need this, yeah. So here's an example that I've used. I have a picture of a legacy power inverter. I have all these different technical data about it. And when I passed it through with a prompt using GPT, you can see I said, like, given this information below, please generate a long product description for the Lenze inverter that would be seen something like in Steve or Informatica. Next, yeah. Then it would generate me this product description that you could put onto the website for that product. And really, you could do this like a simple API call, specify exactly how you want this formatted, how you want your picture to be inserted. All of this can be done. And yeah, so that's pretty much that. Next one, yeah. So how do you start your first AI project? This is a very big part, is to create some sort of AI workflow. And one of my favorite workflows is actually from a book called, it's an O'Reilly book. It's called Applications in Machine Learning with TensorFlow and Scikit-learn. And it gave me these steps. So first, you want to have some sort of big picture. What is your goal? So in that case, before we said, I want to classify a product. Then I need some way to get the data and to ingest it into the data pipeline. So first, I need to discover some insights. I need to do some exploratory data analysis to visualize the data, see which model I could possibly use based on that specific data that we have, which model would fit. Then I would need to prepare it for that specific model. So for instance, if we're doing a neural network, I need to make sure that that the data set is completely clean, that there aren't any sort of NaN values or meta values that it can't necessarily process. So I need to transform them all into numbers. And then I would need to select my model, and then I would need to fine tune the model. So I would train it on that data set that I have. And I would figure out where is it doing the errors, what do I need to improve on to make this model more efficient. And then I would need to evaluate it and then deploy it. And this graph, well, not graph, but figure shows exactly that. You have the data, it ingests this, you organize and clean the data. You need to prepare the data with, for the machine learning model. Then you need to test it and validate your model. And then you have some way of deploying it onto your website or database. So, and a lot of the models or APIs that I use for daily tasks or that are very important to know are right here. For instance, NumPy, pandas, matplotlib is used to, or scipy is used to visualize your data, structure your data, wrangle it, visualize it, and figure out how you could use a model to, or which model you could use. And then we also have your machine learning libraries like scikit-learn and PyTorch to construct your
Okay.
Lastly, we also have the, if you ever want to know anything more about AI or learn something, we have the MSUI Club website. We have a lot of workshops posted there where you can go through and perhaps learn a specific model that you're interested in, like how GPT works or neural networks. If you're ever interested, you can also email us at msuiclub@gmail.com. And that is everything. Thank you very much.
Yeah, thank you very much, Alexander. That was a great presentation. And we are now around about at the half an hour mark. We didn't want to have the presentation too long, so that there is enough time to now ask questions. So, and I would like to open it up now. If you want to ask a question, please raise your hand, and we will then call you up according to what we believe was the order of appearance. You can also write your question just into the chat, and we are happy to pick it also up from there. Right? So it's now open. Anyone having a question or feedback, that's also welcome. No one is having a question. Then maybe Alexander, I will ask a question. You have one of, oh, sorry, there are questions. There is another question here from Gina Bora. I hope I pronounce it correctly. Are the tools being used for machine learning or artificial intelligence similar?
Could I get a clarification on that question? The tools for artificial machine learning. I mean, for instance, a lot of these models that I've discussed here are mostly statistical models, which are machine learning. But as mentioned before, artificial intelligence is more of like an umbrella term that kind of encompasses all of machine learning and deep learning.
Yeah. So
right. So say, for example, can you hear me okay?
Yes, I can hear you.
Yes.
Okay, great. Yeah, so, machine learning is mostly for statistical, but again, you have these analytics tools like Snowflake Click and, Power BI and stuff like that and all. So there was always that variation of, okay, what do I use Power BI for and where do I go for machine learning? What tool sets that are there available out there. And now with this generative AI, where I can still derive statistical data out of it, right? I can ask, for example, ChatGPT that, hey, this is my baseline, this is my last year's numbers. Can you run and let me know, or, can you prepare a similar chart for this year's numbers? And can you tell me what I need to budget for next year numbers as an example?
Yeah.
So now which one is a more accurate tool for me to run statistical data or to, trust on, which technology and, are there tools that kind of overlap in that, understanding of that basic technologies?
Sure. So with ChatGPT, it is useful as a tool to use to maybe get some ideas of how to program something. But a lot of the times GPT hallucinates solutions. So if I were to give it some data set and I would ask it, can you please create these data visualizations and statistical tests, it might just hallucinate a solution. So really, again, it depends on what the problem is that you have. For instance, I want to do sales forecasting. I would maybe use something like a recurring neural network to forecast something into the future. But I would also maybe use GPT to ask, hey, can you maybe help me write this sort of code? Yes, GPT can create insights from statistical data, but in reality, it doesn't really know what it's saying. It's using probabilities to continue off its sentence. I hope that answers the question.
Yes, it does. Thank you.
Okay, wonderful.
Okay, we have the next question. How do you determine what the proper size is for a data set?
So obviously, the more data, the better, usually. If you have, for instance, a lot of columns, but you have not a lot of like data points or rows in your data set, then you might have too little entries. For instance, a good example would be, say I have an X, a Y, and a Z axis, but I only have 2 points, and I want to create some sort of model that fits it. I could create any sort of line that will fit those 2 points. I could create a parabola. I could create just a straight line through it. I wouldn't know what the actual true relationship of the data is. So the more data, usually the better.
Does it answer the question, Dominic? Okay, I don't hear anything, so I assume it does. Then another question, how difficult is it to write an API for automating ChatGPT?
So I haven't done it personally. However, I don't think it's gonna be too, there's probably some libraries out there for Python where you can just do an API call for ChatGPT. I mean, you probably could even ask ChatGPT to write something for you where you could use ChatGPT, but I cannot really answer the question because I haven't personally worked with it before. But I couldn't imagine being too difficult for that to implement such a model.
Thank you, Alex. I have another question, actually. You showed this, these different products, the car, the inverter, and the lobster. How would such a model, which would help to identify what these objects, I call them very neutral, are? How would it look like?
Based on a picture?
Yeah, based on a picture.
So if you have a picture, you could use something like a special type of neural network called a convolutional neural network, which in very most simplest terms, it scans through the picture pixel by pixel and figures out and finds out different parts of these features. For instance, it can figure out like, oh, this is a headlight, this is a tire. And the more pictures that you have of that with a label and train on it, with experience, it will be able to identify this is like a sedan car and this is a truck car. But that's how a model would look like. But if you want to look at the data for that model, it would be more like stretching out all these pixels into like for instance, if you have like a 28 by 28 pixel picture, then it would be 28 times 28 column wide data set, where each column represents a specific pixel in your picture, and then you put that through to your model to make these sorts of predictions.
That sounds interesting. I have another question from Jinal. More on the political side. AI nowadays gets into the news, right? One big example was a strike of actors because they are afraid that they are getting replaced by AI. What do you think? What is the state right now of having policies around AI, and how long will it still take until these are becoming more defined? What is the impression you guys have currently at MSU, for instance?
So from my personal view, what I've seen is that the big issue is how the models are trained based on like data the companies have collected. They're using data that necessarily wasn't consented by, for instance, artists. They have copyright claims on certain artworks and things like that. So it is not very ethical to do that, to train your model on things where you don't necessarily have the consent to do that. However, you also have to be aware that these sorts of models, they can't necessarily create something new. They are trained based on experienced things that they have already seen before. And a lot of the times it does hallucinate solutions, like I've stated previously.
Sorry, could you please go on mute? Whoever is speaking Spanish here.
For instance, where you have this, where was I? For instance, where you have like a data set and you want to say, create the statistical test, and there is some sort of error in its code, and then it still thinks it made the right solution and starts hallucinating these things. So you still need people to understand how you can construct these models and how to interpret these data sets, because in all that GPT is trying to continue on a sentence and with the highest probability insert the next word. But obviously that's very simple of what I said, or simplifies, or it's more very crude of what I said, but that's how somewhat the models work.
Yeah. So there's another question going into that direction. It's Joshua Ians Sekasi. How has European legislation towards AI defined the progress of implementation? I would maybe extend that. To which degree are you guys in what you are doing already impacted or see the impact of legislation, of laws, or any kind of rules which are, or is it free Wild West? How would you see that?
I can't really answer that question because I'm not necessarily that well informed.
Yeah.
I know that there is legislation in the EU where they are trying to create these data protections and what the models are being able to work on, but I don't necessarily, I can't necessarily answer that.
Yeah, and unfortunately also I have to say that I'm not the legal expert here, but well, we are Europeans, we are Germans, Alexander and I, we are from Germany, so, and we follow a little bit the discussion, right? So there is definitely, there is a high awareness here. You see that a lot in the German news. Probably you see that also in the other European news channels. And the European Commission is working right now actively on extending GDPR to actually apply that as well, right? So what will happen to that is to be seen, right? So, and then another very interesting question. What kind of impact will that have on the UK markets? I believe that at the end you will see a pretty uniform way how, unless you are only in the UK market with a company or with a business, you will have a pretty uniform impact on that, because at the same time you have California, which is always at the forefront. You have the European Union, and if you want to do international business, you have to be compliant, right? Also, the other players here have an impact on that as well. Again, we are not attorneys, we are not lawyers. So I think in this case, if you really like to have legal advice on that, I would have to refer you to specialized attorneys. So there's another one regarding AI use cases. What are the team's thoughts of the drunk island analogy by Google's chief decision scientist, Casey Kostyukov? Have you heard about that?
Never heard of it before.
Maybe Jill, if you would like to unmute your phone, I would be interested in what that was.
Yeah, certainly, no problem, Dirk. Cassie Korzakov, she's Google's chief data scientist. I actually heard of it. I was at a robotics session with in Pittsburgh a couple months ago, and it was John Zimmerman. He's one of their professors at the Tepper School of Business, one of their robotics professors, and he actually mentioned Cassie's analogy. He basically said this: there's so much hype about AI and all the different amazing things it can do, and then yet when teams go to actually implement it in the real world, there's a lot of head scratching and why isn't this working? And he described it like this. He referenced her drunk island analogy. Imagine AI as an island of drunken buffoons, and there's a lot of them. And so they can do a lot of things, but you can't give them any instructions. You just have to tell them, hey, here's my task. Here's what I need you to do. And they go and do it. If you ask them something really complicated, of course, they're going to probably put out something that's halfway between nonsense and blarney. But if you know the task, you can define success. And actually, it was in Alexander's slide, one of his early slides about that GEPT model. You have to be able to define the accuracy, right? So in other words, and he had a great example just from the AI use cases that his team, John's team at the Carnegie Mellon University was getting contacted by hospitals, where they were like, hey, could we use AI to maybe look at radiology, x-rays, and sort of define cancerous tumors and all this other stuff? And he's like, oh, no, that is the worst application for AI, because even for humans, just the delayed feedback in knowing when the radiologist makes their diagnosis and eventually finding out if it's actually tumor or cancer or malignant benign, who knows what, it's very difficult to define accuracy. Give me something that your team, this hospital that contacted his group, give me something that's easy, but it's a burden. It's a nuisance. And they were thinking, well, every day we have to come down and before the surgeries, we have to get all the gauze and all the syringes and all the clamps and all the different tools. And we always get more than's needed because, when you're on the table with your gut sliced open, believe me, you want the doctor, the surgical team to have more than they need. So they're not going around looking in the middle of the surgery. But then at the end of the surgery, there's always inevitably stock that wasn't consumed that gets put back into the inventory. Well, that takes time for one of the team members. That they could really be doing much more higher value work than, okay, this gauze goes here, this thing goes there, And he said, that is a perfect use case. That is something where you, the human team, can define success. If that gauze goes in the right box or whatever. We can define algorithms that can detect all that and optimize that for you. That is an example of the drunk island analogy. And so I guess I presume maybe if the chief data scientist at Google had shared it, because I had just heard of it for the first time a couple months ago. So I was just curious what you guys.
Yeah, let me first of all start from my perspective, and then Alexander maybe more with his data scientist perspective. But I come from the MDM perspective. So I see in my IT career, I see a lot of situations where people come up with silver bullets, right? Where just this is the ultimate solution to all your problems, right? And in the end, it turns out in reality it's not. And AI, apart from that AI, as you saw in the presentation deck, you have to define which AI, and it's a widespread definition, right? Apart from that, that is the case. There are two main issues in my opinion, right? First of all, the model and its maker, right? So who made the model and how did he make the model or she make the model? And the second one, the data, right? And if your data is crap, and that is in most cases I see when I start fresh with a customer, with a client, the data is crap, right? Just to summarize it without going more into detail. If you have crappy data, then anyway, you have a problem. And if the model is biased, take ChatGPT, right? I have seen multiple articles where people tried certain things and it was clear that ChatGPT was politically biased, right? So you don't get let's keep a simple example. You don't get the same, to say in the United States, you don't get the same approach to what you get as a response if you ask for a Democrat or Republican. And the same works in Germany with a very partisan situation as well, right? Just because the maker already biased the model. So, Alexander, what do you think about that?
No, I think I agree. Obviously, that when you train a model or select a model, it is important to always look at the data first and see if there are any biases in your data set that could have potential issues. For example, if you want to create some sort of anomaly detection, let's say for the of airports where you're trying to identify whether or not a person might be a risk or non-risk, then if you're using data that might be biased, it could isolate certain groups, which is obviously not right. But also, for instance, with the Drunk Island analogy, which I found very interesting, I actually like that a lot. I'm currently in my research, I'm creating a model that is supposed to speed up a certain simulation for supernova. And the way that I have processed my data isn't good. So, and you can see that as well in the model, it is not performing well, which could also be the case that I've not used the correct model. And there are so many models out there that somebody who might not be as experienced could select a model that just doesn't work. Or even just like asking ChatGPT to create some random machine learning algorithm for the specific data set, and then it chooses a model that isn't even correct to be able to fit. Yeah.
Okay, I hope that helps. We have a couple of more questions. Mr. Kuhn, what platform should a novice, when you just get started, developer, build their first model to learn?
Yes, so I would recommend using Python as a language because Python is very simple to learn because the syntax is very intuitive, and there's also a lot of documentation on a lot of documentation on how to use these libraries. For instance, I had a slide where it talks about must-know packages, which are all Python packages. And furthermore, if you also want to learn more about these things, I would highly recommend checking out our AI Club websites. These are the packages that I was talking about, our APIs. And you can also check out our club where we have recorded workshops or webinars, and also these things called notebooks, where you don't need much coding experience. You can just like read through it and fill in the blanks in some areas. And that is one way of learning that kind of thing as well. But the APIs that you must know, as I've said in the previous slide, can you go back?
Yeah, I can go back. Shall I go back one more?
Are these packages. So, for instance, Pandas is used to clean your data and wrangle it in such a way that it is usable for a machine learning model. NumPy can be used to create, to transform your data into a usable data structure for scikit-learn. SciPy is used for statistical tests, and Matplotlib is, for instance, to visualize your data, and then scikit-learn and PyTorch are those actually the models that, or are actually those APIs and packages that are used to construct your models. And all of them have amazing documentation, especially scikit-learn's, where it goes into further depth of what I talked about today, what the difference is between unsupervised and supervised learning, and all these different types of models that you can use and the assumptions that it makes. So, yeah.
Okay. Thank you very much. Does it answer the question, Matt? I hope it does. Very good. So I have another one.
Yes.
To go into.
Yes, it does. Thank you. Yeah, thank you very much. Appreciate it.
Absolutely. It's a pleasure. So I have one last one, and I think that is an interesting one, and I will answer that. How much is ChatGPT censored or manipulated for a certain political direction or answers? As I said, I read a very interesting article in a German publication where journalists actually, I'm not saying names, right? But they asked ChatGPT in Germany to actually say, what is it called? Sing a poem for particular politicians. And when the politicians were left-wing, they were like very positive, very great. For some right-wing politicians, ChatGPT even didn't want to give an answer, right? So it was pretty clear that for the German part, at least, for the German politicians, it was clearly biased towards one direction, right? So as I said, the maker and the model play a big role here. Again, you would not expect that it's that drastic, but it is. There are more questions here. Well, I think then I want to say, first of all, thank you to you, Alex, again, for this amazing presentation. Lots of insights here, I believe. And again, I want to say thank you to everyone. I'm too early. Someone has another question. And that's an interesting one. We spoke about that before we went here during breakfast, Alexander. What is the role of logistics and AI and machine learning?
Could you clarify what you mean with logistics?
Okay,
So,
Joshua?
Yeah, so currently I work in the logistics sector. So we deliver parcels across the UK and externally all over Europe. So basically the parcel sector and also supply in terms of retail, how would machine learning and AI affect that, or how will it be implemented in terms of that area, if that defines it better?
You could use some models to, for instance, optimize the, I guess not supply chain, but how optimize maybe the routes of certain parcel deliveries to go from point A to point B, using data that you had previously. For instance, if you have data about like how delayed a certain certain parcel delivery route is, you can use a machine learning model, given all that data, to predict how late something might be, and maybe even improve your your chain from there to isolate those errors. So you could use something like a machine learning model to do that, maybe, which would probably be used like regression or classification to classify whether or not a parcel will be late, and then regression would be used to how many minutes or how many hours or days that parcel might be late.
Did you have a particular use case in mind, Joshua?
Probably utilization within parcels. We have a current issue with missing SLAs and predicting when the SLAs are currently being delivered. So, for example, a company like ASOS, they're currently asking why their parcels are missing, not predicting 97% of parcels are being delivered on time. And we need to find the reasons why. How could like a machine learning or an AI algorithm help build that case in the future?
So you could use a regression model, like I said.
Sounds like an interesting use case.
I'm sorry. Yeah, you could use like a regression model, like I said, and then you can analyze how that regression model weighs more on certain columns of your data. For instance, it could, if you have like a weather column and it was raining or it was snowing, then you would be able to see that the model would be more influenced towards one direction than another, and you can isolate the error that way, or the reason to why a parcel might be delayed.
Thank you. Cheers.
Yeah, and of course, now we are getting very soon towards the end of our allotted time frame, and I want to respect everyone's time as well. But if you have any more questions, feel free to ask them also directly to us. You can chat me and LinkedIn, or of course send emails directly to the club. Based on the email address, we'll send this presentation around. And again, I want to say thank you to you, Alexander, for this amazing presentation and for all the insights you provided. I want to thank you, everyone, for taking the time. A lot of you stick to the end. I hope it was worth it. I assume so. And again, if you would like to know a little bit more, or even discuss with us directly, or speak to Alexander directly, feel free to approach me. Thank you very much, everyone. Enjoy the rest of the day, wherever you are here on this planet. Thank you very much. Bye.
Bye-bye for now.
Bye, thank you.
Bye.